All right, this set of notes should be pretty short and sweet. So this time we're just talking about in a diagram what can be assumed and what needs to be labeled. So I've been telling y'all how important it is to make sure you label correctly and that you use the right symbols and that your eyes need to be able to read a picture. So this is kind of where this all comes into play. So we're going to be able to identify some postulates using diagrams, and we're going to be able to sketch and interpret diagrams as well, meaning we're going to be able to draw our own pictures. So first thing, first part is fairly simple because we're just going to be looking at the different postulates. Some of them kind of go forward and backward. 2-point postulate says through any 2 points there is exactly one line. So no matter what. So there's points A and B. So since there are 2 points, I can draw a line. So through points A and B there is exactly one line. You cannot draw another line through A and B. I can add another point and I can add another line, but there's just one line through 2 points. And then of course a line contains at least 2 points. So basically a line is just a bunch of points, but it has to have at least 2. We have a postulate that says line intersection. In other words, 2 lines intersect. They intersect at exactly 1 point. They can't intersect anywhere else. That is exactly where they intersect. Kind of like 2 streets. You got this street going this way and you got this street going this way. They intersect right here. They're not going to intersect anywhere else because that's where they meet. We have a 3-point postulate. Says through any 3 non-collinear, so they have to be random, there is exactly one plane. If they were collinear, it wouldn't be a plane, it would be a line. So through any 3 non-collinear points, there is one plane. Then we have the plane point says a plane contains at least 3 collinear points. Then we have the plane line postulate, which says if 2 points lie in a plane, so I have D and E here, then the line containing them is also in the plane. So in other words, if you have a plate, think of it like this. Okay, so think of it like this. You have a plate. So if I were to have a plate and there were 2 peas on my plate, so I have 2 peas on my plate, then I can connect those 2 peas with a line, and that line is also on my plate. All right, so here, if 2 planes intersect, their intersection is a line. Think of where your ceiling and your wall meet. The corner is the line, so there's exactly one corner. All right, so in these, we're just going to do, okay, if I'm giving at least 2 points, then there is a line. That is the 2-point postulate, and it says, if given 2 points, then there's exactly one line. So that's kind of how you know what postulate you're using. Like, if I give you this, then you can assume this. You can never... Okay, so here we're given a plane with some points in it. So if we're given a plane with some points, then there's a plane with a line. So that would be the, well, let me erase that. So this is the plane line postulate, and the plane line postulate, let's move it where we can see it. The plane line postulate says if 2 points are in a plane, then the line containing them lies in the plane. Then we have to draw. So I'm telling you to draw a ray that's bisecting a line at a point. So here is line KL. It's being bisected by ray RS at point R. So that's all you got to do is just look at what you have and draw what you need to. So here we have line AB. So here's line AB. It's in plane U, and it's intersecting line CD. Here's line CD at point E, but point C is not on the plane. So in other words, you got to think about this as, okay, you've got this flat surface. Think about a piece of paper and you stick a pencil through it. The pencil tip, the lead of the pencil, point C, is not on the plane. It did go through the plane, but it's no longer on the plane. So it's kind of poking out the bottom, so that's kind of why it looks like that. Now I have a line that's intersecting a segment at a point, and part of the segment pieces of the line are congruent. So that means that W is a midpoint. So for TW and WV to be congruent, W has to be a midpoint, and that segment just goes through there. It doesn't matter which direction it's pointing. All right, and the last thing, we're going to look at the picture, and from the picture we're going to determine if things are true or false, if we can assume them or not, and we're going to talk about why. So planes A and B. So here's plane A, that's the shaded one here, and B is this one going this direction. They intersect at line EF. So there's line EF going through them. So remember, true, two planes intersect at one line. Points C and D are collinear. So here's C and here's D. There's not a line drawn, but we know from that postulate, that any 2 points are collinear. HJ is this ray, and ID is this line here. Are they perpendicular? Yes, they're perpendicular at H, because that is the right angle. So that's how I can assume that they are perpendicular. Line GD is a bisector of line EF. So GD is this line right here that's going along this plane. EF is this line here. And it says that it's a bisector at EF. Yes, that's true, because ED is congruent to DF. The marks are in the picture. IH equals HJ. So IH is from here to here. So here's IH. So let's see if I can get this to draw here. So here's IH and HG. It does not tell me that they're congruent, so they're not. So false, it is not marked or told H is midpoint. And then I have angle HJD, and HDJ, which is this one over here, are complementary angles. This is a true statement because angle H is a right angle, and the triangle is a right triangle, so that means those two angles have to add up to 90. So pretty short and sweet, easy lesson, and I will see you guys later.